Hello, and welcome to Joseph and Gabriel's science experiment. Today we will be measuring the thickness or viscosity of fluids. The fluids we will be measuring today are water, hand sanitizer, cooking oil, and dish soap. We will be putting these liquids in these graduated cylinders, which will be measured in grams on this scale. We will be measuring the displacement of these marbles as they make their way through the fluid to the bottom. Our hypothesis for the experiment is that objects moving through fluids with a high viscosity will move much more slowly than fluids with a low viscosity. Higher viscosity fluids will also weigh more than lower viscosity fluids. We will start off by measuring the weight of each graduated cylinder in grams. The water cylinder weighs approximately 11 grams. The sanitizer cylinder weighs 11 grams as well. The dish soap cylinder weighs 11 grams. And finally, the cooking oil cylinder weighs 11 grams. They all weigh the same. Next, we will measure the mass of each marble so that we know it will displace each fluid equally. We will start off by zeroing the grams of this cap. Now, we will start measuring the 4 marbles. The first marble is 5 grams. The second marble is also 5 grams. The third marble is 5 grams. And finally, the fourth marble is 5 grams. Now we know that each marble will displace the fluids equally. Now we will measure 30 milliliters of water on this scale, minus the weight of the graduated cylinder. 30 milliliters of water weighs 37 grams. Second, we will measure 30 milliliters of sanitizer on the scale, minus the weight of the graduated cylinder. 30 milliliters of sanitizer equals 37 grams. Third, we will measure 30 milliliters of cooking oil on the scale minus the weight of the graduated cylinder. 30 milliliters of cooking oil weighs 31 grams. Last but not least, we will measure the weight of 30 milliliters of dish soap on the scale minus the weight of the graduated cylinder. 30 milliliters of dish soap weighs 37 grams. As you can see, each fluid was measured with 30 milliliters. We record our data for examination of the experiment. As you can see, the water weighs 37 grams. The sanitizer weighs 37 grams, and the dish soap weighs 37 grams, while the cooking oil weighs 31 grams. We will now measure how long it takes for the marble to displace itself through the water. As you can see, the time is 0.18 seconds. Now we will measure how long it takes for the marble to displace the sanitizer and reach the bottom. 3, 2, 1. As you can see, even though the sanitizer may weigh the same as the water, it is a lot thicker, so the marble takes more time to displace the sanitizer and reach the bottom. The marble is now starting to reach 10 milliliters. It is now coming to the bottom. There. And it has now reached the bottom. So it appears that the marble has taken 47.62 seconds. Now we will measure how long it takes the marble to displace itself through the cooking oil. 3, 2, 1. Since the cooking oil isn't very thick, the marble immediately reached the bottom, and it only took 0.15 seconds. Now we will measure how long it takes the marble to displace the dish soap and reach the bottom. 3, 2, 1. As you can see, the dish soap was a little thick, so it slowed down the marble and made the time 0.74 seconds. Now, Gabrielle and I put our results together in a trifold. First, we started off with the question, which was, how can we measure viscosity? And viscosity is defined as the resistance of a substance or liquid to flow. For example, water has a lower viscosity than molasses and flows more easily. This quote was found on dictionary.com. Now we moved on to our hypothesis. Part A of our hypothesis was, an object moving through a liquid with a high viscosity or thickness will move much more slowly than an object through a liquid with a low viscosity or thickness. Part B of our hypothesis was, higher viscosity fluids will weigh more or have a larger mass than lower viscosity fluids. Now we move on to our materials, which was 4 graduated cylinders, 4 marbles, a stopwatch, a notebook and pen, a digital scientific scale, cooking oil, syrup, hand sanitizer, and water. Here are the fluids that we had used during our experiment. The water, the cooking oil, the dish soap, and the sanitizer. Now we move on to our experimental data chart. Our volume was all 30 milliliters. Our time, the greatest time was sanitizer. All of them weighed the same except for oil. Oil had the highest velocity but lowest viscosity, and sanitizer had the lowest velocity but highest viscosity. Here we have our charts with the liquids, their volumes, which all measured to 30 milliliters, the time in seconds, the weight in grams, and the velocity in milliliters per second. Now we move down here to the conclusion chart. Hypothesis part A, the higher the viscosity, the lower the velocity, is correct. Hypothesis part B, the higher viscosity fluids weigh more than lower viscosity fluids, is incorrect. The first one is correct because the lower the velocity, the higher the viscosity, was proved during our experiment. The second one, the higher viscosity fluids weigh more than lower viscosity fluids, is incorrect because the oil weighed less than the soap but had a higher viscosity. Now we move down to our procedure, which is what we did in the experiment. We zeroed the scale with an empty graduated cylinder so that the liquid is measured. Then we weight checked each marble so that the same amount of liquid is being displaced. Then we filled each cylinder with the same amount of different 4 liquids. We weighed each of the 4 liquids and recorded each liquid in grams. Once the partner drops a marble into the fluid while the other partner times the marble's fall with a stopwatch. We record the fluid time it took for the marble to displace the fluid and fall from the top of the fluid to bottom of the cylinder. We calculate the velocity of the marble through each liquid. Here are some of the formulas we used. Velocity equals displacement divided by time. Velocity is the rate of displacement. Displacement is the movement of the marble, or volume of liquid in milliliters. Time is stopwatch data, measured in seconds. Now we measure and record the data in tables and graphs, which we explained up here. Now we finally move on to the recorded data for measuring the experiment. Here we have the liquids, water, oil, soap, and sanitizer, how they all had 30 milliliters in volume, how they each had all their times, which is 0.18 for water, 0.15 for oil, 0.74 for sanitizer, and 46.62 seconds for sanitizer. Now we move on to the weight in grams. All of them weighed 37 grams except for the oil. Now we move on to the velocity in milliliters per second. Water had 166.67 meters per second. Oil had 200 milliliters per second. Soap had 40.54 milliliters per second. And sanitizer had 0.64 milliliters per second. Now we finally move on to the analysis. The analysis during our part A was, during our experiment, we timed how long it took a marble to displace itself through 4 different liquids at equal volumes. Each liquid, being different in molecular makeup, affected the velocity of the marble as it displaced a given volume of liquid through time. When liquid particles or molecules move over objects easily, it is known to have a lower viscosity. However, when a liquid particle moves over an object with difficulty, it is known to have a high viscosity. Therefore, when the marble moved through each liquid, we were able to measure the viscosity of each liquid by the rate of the marble's velocity or displacement through the liquid. Now our hypothesis part B. It was noted that the hand sanitizer, dish soap, and water all weighed 37 grams, with the cooking oil weighing 31 grams. Although the hand sanitizer had the highest viscosity, it did not weigh any more than the dish soap and water, which had much lower viscosities. Finally, we move on to the conclusion. Hypothesis part A. Sanitizer proved to have the highest viscosity because the marble dropped into it took the most time to displace itself through the liquid. Cooking oil had the lowest viscosity by having the amount of time for the marble to displace itself through the liquid. This concluded that part A of our hypothesis was correct in stating the higher the viscosity, the lower the velocity, because the sanitizer had the highest viscosity and the lowest velocity. Our second hypothesis was incorrect because the fact that the sanitizer weighed the same as 2 of the other liquids, which was the water and dish soap, yet it had the higher viscosity, it proved that a heavy molecular liquid does not mean that it will necessarily be higher or lower in viscosity. Viscosity is based more on how easy the molecules move against each other instead of how much they may weigh. This concluded that part B of our hypothesis was incorrect, stating higher viscosity liquids would weigh more than the lower viscosity liquids. And that is the end of our science experiment. I hope you enjoyed it. Please like, comment, and subscribe. And I'll see you next time.